Hello everyone, welcome to today's edition of our Google Cloud Fundamentals Core Infrastructure Lab. For today, we are going to explore automating the deployment of infrastructure using Terraform. Terraforms enable you to safely and predictably create, change, and improve infrastructure. Terraform is an open source tool that codifies API into declarative configuration files that can be shared among team members, treated as code, edited and reviewed, and also versioned. Terraform was developed by the HashiCorp organization, and it helps provision infrastructure resources. It can also help us to manage config files or serve as a source control to maintain and also provision states for testing and production environments. Infrastructure as a code, which means provisioning infrastructure through machine-readable definition files rather than physical hardware configurations or interactive configuration tools. The Terraform works on the principle of infrastructure as a code. And some of the advantages of using Terraform is that it provides an infrastructure lifecycle management. It's also a version control commit, and it is very useful for stack-based deployments and with cloud providers such as AWS, GCP, Azure, and Kubernetes. It also provides a state-based approach to track resources changes throughout our deployments. The Terraform is something that is very useful, especially when you want to use it for infrastructure deployments with code. So for today, we would explore how we can automate the deployment of infrastructure using Terraform. So let's get started. First thing is to after that, then you open in an incognito window. That's a good strategy to open in an incognito window. Then next, so I have to copy my password, then paste it here. So it's configuring my Cloud Shell. So here is my home page on Cloud Shell. So the first thing is I want to open our Cloud Shell. I need to provision our Cloud Shell machine and connect to our Cloud Shell instance. So yeah, here we have. So the next thing, following the instruction, we've done this setup. Now the first task is to set up Terraform and Cloud Shell. So I've activated Cloud Shell, so I'm just going to set up Terraform here. So you can see this is the Terraform version here, and this is the Linux version here. So the next thing I want to do is I want to create a directory in our cloud editor. So I'm naming this directory tfnir. So I've made that directory. Then I have to go to our cloud editor by clicking on this. So here we are on our cloud editor. I'll open it in a new tab so that I can switch in between our Cloud Shell and our cloud editor. Setting up our cloud editor. So it's going to set it up. Yeah, and you can see the directory we created here. So the next thing we have to do is we have to initialize Terraform. And to initialize Terraform, you have to first create a folder in our tfinfra folder. We would name the file provider.tf. So going back here, so create a new file. Okay. So after creating a new file, our new file is created. Then we have to copy this code into it. Here's the code. Then it's more often than not the cloud editor saves automatically, but just to be sure, I'll be doing file and save here just to be double sure. So, or you can just use Ctrl S anyhow you like. So we've done this. The next thing we want to do is we want to initialize Terraform, and to initialize Terraform we have to do that on our cloud shell. So I have to go to my cloud shell. So I'll open the terminal back and I paste the code. So I have to first cd into the directory, which is the tf-infra, then I run the Terraform init command. Yeah. So our Terraform has been initialized, and you can see that we have this command here. So that's all with task 1. For task 2, to create mynetwork and its resources. So we'll create the auto mode network mynetwork along with its firewall rules and 2 virtual machine instances. We'll name the virtual machine instance mynet US VM, in that one in the US region, and the mynet EU VM, that one in the Europe region. So the first thing we have to do is also to create another file. We'll name this mynetwork.tf. So going back to our cloud editor, we'll create a new file here and we'll name this. So after naming this, we have to copy the expected code. So we'll copy this code here. And what this code is doing is we are creating the mynetwork network, and this will be the resource type, this will be the name. So go in here. So there's a little bit challenge with this code because it is not well formatted. This is just a placeholder. I would replace this with a new value in the next step. Okay. Yeah, so the next thing we want to do is we want to replace the resource type with Google Compute Network. So, and make sure that you are copying the quotes in between them. So I'll replace this, and you can see that it's not more showing any error. Then next thing is to save. So after saving that, we also have to add an auto create subnetwork command, and we are setting it to true because we are setting the auto create subnetwork to 2. We want an auto mode network to get created automatically. So that's what we are going to do here, and we are going to set that to 2. So here we are. Yes, and you can verify that our command just looks like this. So take a look at it. It's the same thing. And the next thing I want to do is to save this. I've saved this. Well, just do one more time. So after that, we have to configure the firewall rule, and we define a firewall rule: HTTP, SSH, RDP, and ICMP. I have a video on configuring firewall rule. You can check it out. I'll link it up here. To configure firewall rules, and to configure firewall rules, we are just adding the firewall configuration in the same mynetwork.tf file. So I'll copy this. After copying it, I'm going to paste it here. So after pasting it, I have to replace the resource type with this name, changing the resource type with this. So change the resource type here. Then I would also change the resource name, and I'm replacing it with this here, with the quotes. Here's our resource name, changing it. So after doing that, the next thing we want to do is we want to add the following property, which just means that we want the firewall to depend on its network, the network we are using, so that we are setting the network to Google Compute _network.mynetwork.selflink. So we are instructing Terraform to resolve these resources in a dependent order. So that means the network is created before the firewall. So just going to add the properties just below this. Yeah, and you can see it here. So save again, Ctrl S. Here. The next thing we want to do is we want to add the necessary protocols for our firewall rules. We want to allow the ports that's going to be able to connect to this virtual machine instance. So adding that just below it, we had the allow protocol rule here, and we've allowed that. So the next thing we want to do is you can confirm if this is exactly how it is. So just taking a look at it, Let's see. So I'm just supposed to bring this down here. Yeah, so now we can save again. Saved. So the next thing we want to do is to configure the virtual machine instance. So you have to first create the virtual machine instance folder, and then we now create a file inside that folder. So the folder we'll be creating is name it instance. So just under this, we create a new folder. I'll name it instance. I'm just going to clean the trailing white space. Here's our new folder instance. Then inside this one, we create a new file and we'll name it main.tf. So it's created now, and you can see just like this, same thing we have here. So the next thing, we want to fill in the main.tf with the necessary configuration with the necessary code for our instance. So you copy this, you paste this there, and don't forget you have to change this resource type. So we'll change the resource type with this will complete instance here. It's going to change this resource type here. Then we would also change the resource name. So you are replacing the resource name with this. Please make sure you are copying it with your quotes so that you don't run into error along the way. So after doing that, click on file and save one more time. So we also have to add some properties to our main.tf, because we are creating a virtual machine instance. We have to put a zone, we have to put a machine type and some other parameters. But for now, we've only just set the resource type and the name. So now let's set the zone and the machine type. So just here, set the necessary zone and machine type. And the other thing we want to do is, so this property that we sent, that we inputted here, just tells us to define this zone and machine type of the instance as input variable. So then we want to add the both disk parameter. So here we are using a Debian cloud, a Debian 11 OS image. So pasting it just below it, the boot disk configuration. So after that, also would also add a network interface. So because we want our network interface, we have internal IP address, we have external IP address also. So we are setting this configuration here so that we can define the network interface by providing the network name as an input variable and the access configurations. So pasting this network interface. Okay, I think it's fairly well indented. Can keep this a little bit. Yeah, so just look like this now. Can verify that it looks like this. So the next thing I want to do is to save. Don't forget to save. So start saving it. We've created the main.tf and we've input it with the necessary code. So the next thing we want to do is we want to also create a file for our variable inside our instance folder. So all the variables that we would use, we've set something as a variable input. So all those variables, we have to name them in the variable file. So create a new file once again. Name this variable.tf, click on enter. So variables like this, var.instance name, the zone, the machine type, and the network, we have to configure them or specify them in the variables.tf. So we are defining these four variables: the name, zone, type, and the network. So pasting this here. After pasting this here, so the meaning of using defaults, using the tag default here means that we've set the default of the variable instance type to into my code, but the other one we have to specify it. So yeah, don't forget to save. It's going to save. Yeah, and the next thing we want to do also is that, so since we've set the variables, we now have to specify the values for those variables inside our mynetwork.tf. So going back to our mynetwork.tf, we would go there and specify those variables. Here's our mynetwork.tf. Then come here and specify those variables here. So this is our source. This is the instance name that we are using. Mynet US VM. This is the instance zone US Central 1. This is the instance network. And we are creating, since we are creating two virtual machine instances, one in US and one in European Union EU. So these are the configuration for both of them. Yeah, cool. Save one more time. Yes, you can see, you can take a look at this instruction here, but we've explained it before. The Google _compute_network.mynetwork.self_link is just to instruct Terraform to configure the resources in a dependent order. That means create the network first before the instance. Yeah. So verify that your mynetwork.tf looks like this. So if you are not sure, you can just copy this and paste it there directly. But since we followed all the whole instruction, I guess it's pretty much like this. So you can do a double check on it to be very sure if you are missing any indentation or any. Yeah, so I think we are good. So the next thing we want to do is we want to create my network and its resources. So to do that, we have to go back to our Cloud Shell. Here we are on our Cloud Shell. So I'm just going to reconnect. So if you notice that your Cloud Shell lost connection, just reconnect it and you're good to go. So paste this code here and click on enter. Just going to run it again. Yeah, so I think it has been configured, but I'm just going to refresh this. Yeah, so we've configured our Terraform.fmt and you can see the result here. We've configured the Terraform fmt and you can see the result on network.tf. Yeah, so the next thing we want to do is we want to initialize Terraform with the code Terraform init. So after initializing Terraform, you can see that our Terraform has initialized, and it has initialized the following modules: the Mynet EU VM, the Mynet US VM, initialize the necessary backend, and everything is up now. So the next thing I want to do is I want to create an execution plan for it with Terraform plan, and we'll see the execution plan that Terraform is going to do for us. Okay. Yeah, authorize this. Yeah, so you can see that now our plan has been created and we have our Terraform plan here. So these are the 4 plans that got created for us. The first one is the Google Compute Firewall.mynetwork, allow HTTP SSH RDP. So the firewall is going to get created first. Then the next one is the network. Then it's also going to create the compute engine instance virtual machine. Then the last one is going to create the compute engine virtual machine for the European Union. Then it's going to create the one for the US region, and those are the 4 things that's going to get created. So here we are, you can see them. The next thing we want to do is to also now apply the desired changes. So here are the things we want. So now let's apply it. So with the Terraform apply, so that's applied all this. So to approve the application, so you can just go over it against just the same thing with what it showed us the other time. It's going to do the firewall, create the compute engine network, then to do the Europe virtual machine, then do the US virtual machine. So let's go to put yes here to show that I want it to get created. So you can see it's creating. It's going to get created. So it may take a while. I'll probably fast forward it and see at the end. Yeah, so we are done, and we can see that it has added the 4 resources, 0 change, 0 destroy. Good. So the next thing we want to do is let's verify if we've completed this. So yeah, assessment complete. For task 3, we have to verify our deployment. So to verify our deployment, let's first take a look at the VPC network that got created, and let's check the firewall rules and the necessary network here. So from our VPC network, you can go to VPC network. Just going to change on the UI tab. So this default comes more often than not. It's all projects that you create on GCP, but this is the mynetwork that we just created now. So you can take a look at it, and you'd see that it has a network in each region. So this is it. It has in US, Europe, US restaurant, like almost everything here. Okay. The next thing is let's check the firewall rule and see the firewall rule that we actually created. So you can see this is the mynetwork allow HTTP, SSH, RDP, and ICMP, and that's what we specified. These are the ports that we specified. You can see them here. So this is just at the priority level, and you can click on it to see. Yeah, so these are just everything, and this is the firewall for Mynet EU VM and the firewall for Mynet US VM. This is their internal and external IP address. So we are good to go. Then the next thing we want to do is we want to verify our virtual machine in the cloud console. So we want to see if both of them we want to test the connectivity from the US virtual machine to the Europe virtual machine. So we want to see if they both connect to one another. Since we've allowed ICMP traffic, so that means both both virtual machines should be able to connect with one another, since they're on the same network. And the virtual machine also allows ICMP traffic. So what we are going to do is go to the compute engine. What we are going to do is go to the compute engine. So back here, click on the navigation menu. Here we are on compute engine, virtual machine. So you can take note of this internal IP address and external IP address to get that data. So what we want to do now is we want to SSH from our US virtual machine. We want to see if we can talk to the EU virtual machine. So we have to first SSH into the US virtual machine, then we put the internal IP address of the EU virtual machine here. So let's just copy this code out. So the next thing is go to our US virtual machine and SSH into that. So after SSHing into that, so let's wait for our SSH to get configured. Okay, so let's ping, then let's change this with our EU virtual machine internal IP address. So let's copy our EU virtual internal IP address. This is the internal IP address. So copying it right there. So this is our SSH. So paste it here. Let's see. Yeah, so you can see that we can talk to it. Why you can see that, you can see 3 packets transmitted and 3 packets received, and it's telling us that 0% packet loss. So there was no packet loss, all packet was successfully received. That means the US VM can talk to the one in EU VM. You can also go one step further and test for the other one. Maybe I'll just do that so that you can be very sure. So let's SSH into this other one. Just going to cancel this. Let's SSH into this other one. Then let's ping into it. So let's copy this once again. Let me just copy this here. Then let's wait for the SSH keys to get created. So then we'll see if we can also talk to the other one. So now I'm going to copy the internal IP address of the US one. So on our virtual machine here. So let's copy the internal IP address of the US one. Paste it here and let's see if we can also talk to it. Yeah, so you can see that this can also talk to themselves. So both of them could communicate with one another, which is good. You just cancel out of the SSH shell. So the next thing we want to do is, yeah, that's basically all for this lab. We've seen how we could configure a virtual machine instance with Terraform, and we just do that with using code. So we did not do anyone using maybe the cloud shell or using the console. So we did everything on Terraform, which is an infrastructure as a code tool that helps us to manage config files, source controls to maintain, and also provision state for testing and production environments. And going over the review of this lab, so we use Terraform with a module to automate the deployment of Google Cloud infrastructure, and Terraform can create incremental execution plans which allows us to build our overall configuration step by step. So you can see we outlined 4 steps for you to follow, which was create the network, set the firewall rule, then create the virtual machine, one in the US, create the other one in the European Union. So that's something you can do with Terraform. You can do a whole lot of configuration, a lot of tools. You can configure a lot of infrastructure using Terraform at a go. So, and likewise, the instance module also allowed us to reuse the same configuration for multiple resources while providing properties as input variables. So when we were creating the 2 virtual machines, one in the EU and one in the US, so you can see that we just use the same configuration and we just change the input variables for each and every one of them. So you can leverage these configurations and modules that you created as a starting point for future deployment. So with Terraform, a very, very powerful tool that can help you in configuring your execution plan or doing incremental execution plan or deploying or automating deployments on Google Cloud infrastructure. And that's all for now. So don't forget, you can also do very much more than just this lab. Make sure you check out the official documentation or learn more about how you can use Terraform on GCP to automate deployments and also configure infrastructures on GCP. So thanks very much for staying true to the end of this lab. If you enjoyed this lab, make sure you smash the like button, comment your thoughts in the comment section, so I want to see your thoughts on this lab. And if you have any other lab you want me to explore, put it in the comment section and I'll make sure I talk about that. See you in the next lab. Bye for now.